Hello, this is question 6 on your specimen 2018. It's a probability question with Venn diagrams, and I'm going to show you how to get full marks on it. So you have three events, A, B, and C. They give you some probabilities, so they give you probability of A, probability of C, and probability of A union B. And they tell us that A and C are mutually exclusive. I have to represent a Venn diagram at the end, so for the last part of the question, but I already represented, so we have an idea of what's happening. A and C are mutually exclusive, so that means they don't have intersection. You always can represent these bubbles all together with an intersection and write the probability in the middle is 0, but if you know they are mutually exclusive, I would recommend you to represent this way, so with A and C completely separate without intersection, so you don't get mistakes. They are asking, first of all, probability of A union C. So A union C, as I don't have intersection, is just the sum of probability of A and probability of C. So it's quite simple. Probability of A union C is going to be probability of A plus probability of C, just because I don't have any intersection. So this is going to be 2/5, which is given, plus a probability of C, which is 1/2, and this is 9/10, or 0.9. It's up to you if you just write this way. This is 1 mark, so you have your first mark here, right? This is A. Let me write. This is A. Then B is 4 marks. They tell you that A and B are independent, and you have to find probability of B. So if A and B are independent, that means that the probability of the intersection, so A intersection B, is probability of A times probability of B. That's the condition for them to be independent. So we don't know probability of the intersection. We know probability of A, which is 2/5. You have it up there, so 2/5, 2/5, probability of B. But still I have two things that I don't know, probability of B and probability of the intersection. But I have another formula that gives me some connection between both of them, which is this one. So you know probability of the union is going to be probability of A plus probability of B minus probability of the intersection. So probability of the union is given, so it's this one here, which is 5/8. So I have 5/8 is probability of A, which was 2/5, plus probability of B is what I need, minus probability of A intersection B. So if you see, you have one equation here with two unknowns, and one equation here with the same two unknowns. So we can consider these like simultaneous equations. For this part of the question, for the first part, for using the fact that they are independent, you get 1 mark. For using this second formula, you get another mark. For using this formula, you get another mark. For substituting correctly, you get another mark. Or for the correct method between, not for substituting, but for what we can do to find PB here is just substitute what a probability of the intersection is in this equation. So for that you get another mark. Let me substitute. So I'm going to put this one here. So I have 5/8 equal to 2/5 plus probability of B, that's what I'm looking for, minus, instead of probability of A intersection B, I'm going to write this. So this is your other mark for substituting one into the other correctly. So this is another mark. And when you have that, you just solve the equation for PB, and then you have that probability of B is 3/8, or 0.375, which is your 4th mark here. This one. So this is B. Then you have for C, it's just 1 mark because it's quite simple. Probability of A given B. So I'm going to do here, and you have for C, probability of A given B. Remember, this is the probability of the intersection of A and B divided by the one that is already happening, which is B, the second one. Probability of A intersection B, I can find it. I don't have it yet, but I can find it from here. So probability of A intersection B is 2/5 of probability of B. So I'm going to do it just quickly. Probability of A intersection B is 2/5 times 3/8, which is, I don't have it, but it's 3/20, right? So I can substitute here 3/20 divided by probability of B, which was 3/8. So this probability is 1/5 or 0.20. Yeah, and this is your mark, your single mark in this part of the question, in question C. Then D, they are asking us to draw a Venn diagram. So draw a Venn diagram to represent all the events. So I think I'm going to copy the Venn diagram in the other page so we can complete it. And we are going to start to complete what we found. They give us something else. They tell us that given that the probability of no C intersection no B is 0.3, so they are telling us something else. How does that help? So let me do it. Is probability of no C intersection no B is 0.3. This is one other clue. Can we complete something? We can complete, for example, the intersections if we have them, because we found this intersection here. So probability of A intersection B is 3/20 or 0.15. So this is 0.15. So this is the intersection between A and B. This is this number here, between A and B, so 0.15. If we have this intersection, as we know probability of A, we can find this bit here, which will be probability of A, which is 2/5, so 2/5 minus 0.15. That bit here is 0.25, so 0.25. Then we know probability of B, but we don't know which number goes here and which number goes here, so we cannot complete that at the moment. And again, probability of C, but again, we don't know which part goes here. So this is when we are going to use this bit. This is probability of no C intersection no B. No C is everything around C. No B is everything around B. So the intersection of both of them will be this number here and the number outside. So everything that is outside both of these together. I know all the numbers will add up to 1. So what we're going to do to find that number is 1 minus 0.25. No, I'm not doing it right. So 0.3, which is all these together, the no B intersection no C, is going to be 0.25 plus the number that I have outside. So it's 0.25 by, I'm going to write X, my number outside. So my number outside is 0.05. 0.05. So I have used this already. What else we can use? We know that the probability, if we are able to find this intersection, that would be the way, because when we know this intersection, we would know how to fill this and this. So let's see how we can find the intersection. We know again that the union, B union C, is going to be probability of B plus probability of C minus probability of the intersection. Probability of B union C is this together, right? Which will be 1 minus this number and this number, right? Because it's everything here inside will be 1 minus this number and this number. So I have 1 minus 0.25 minus 0.05 is the probability of B union C. Probability of B is given and is 3 over 8. Is 3 over 8. Probability of C is 1/2, or 0.5, and minus probability of B intersection C. So from here, I have the probability of B intersection C is 7 over 40, or 0.175. So this is the probability of B intersection C. That means that we can complete this number in the middle, so 0.175. And now I know probability of B altogether. If I take away 0.15 and 0.175, I have what I have in the middle. So probability of B was 3/8, or 0.3785, minus 0.15 minus 0.175 is going to be the number here in the middle, which is 1/20, or 0.120, or 0.05. So this is this number here. And for the last one, I know the probability of C, which was 1/2, so 0.5, minus this bit here, 0.175. 175 is going to be 0.325, and it's this number here, 0.325, right? Marks. So you have 1 mark every 2 numbers that you have correct. So you have 1 mark for doing the Venn diagram in the correct shape, disposition, even without the numbers yet. Then you have another mark for the 0.15 and 0.15 and 0.25. So for these 2 numbers here, you have another mark. I don't know where to put the mark. Yeah, but this for these 2 numbers. Then for the 0.175 and 0.35, so for these 2 you have another mark. And for the last 2 numbers, the 0.25 outside and the 0.25 inside, so these 2 you have another mark. And the last mark is for have the whole Venn diagram completed and correct, with all the numbers correct. Yeah, I know it's difficult to see where every mark goes, but it's the way. So it's 1 for drawing the Venn diagram in the correct way, 2, 1 mark more or less every 2 numbers, and 1 mark to have the whole thing completed. So it's 5 marks in total. Yeah, which is this one. And this is all for this question. Hello! If you like the video, I have a free last-minute revision course the week before your exams. The link is in the description below. I'm working with international levels for Edexcel, but if you are an UK student, you will find this very helpful as well, because the questions are identical, you just have less topics. I have other courses through the year. They are all in my website, and the link is as well in the description below. I would love to help you.